Okay, now we're going to take the part and we're going to turn it and we're going to lock it in over here, leaving just a little bit out so that we can find the center or zero one of the edges. This is going to be a little more complicated. You're going to have to start by measuring the diameter of your end mill. How big is it going to be? So you can just measure it right here, tip to tip. It's a little harder to do it from the flutes, but if you get at the very tip, and if it reads a little bit off, it's going to be a standard dimension, and I have that in a description as to what it's going to be. This is a 1/4 inch end mill, and so it's going to be taking out 1/4 inch at a time. And I have something to figure out where you want to calculate this. Let me go ahead and put this in place while I'll try to explain this a little bit. What you have to do is figure out where you're going to have your where the edge of it is. And you know what I would like to do is take about 50 thousandths off at the very end and run this machine all the way around till it there we go. We know where it's going to be in this direction. The 0, 0 is up here. You'll notice that the 0 is actually the center of the cutter in this case. And so we're going to orient our piece like this, and we're going to figure out, well, actually, I shouldn't have put the end mill in. I should have had the edge finder in. Just a second. This will be much easier because I was having to put the other one in from the whole collet. Okay. Now here we're only going to find 1, 0 with the edge finder. Because it's going to be lined up on the edge. You'll see what I mean in a minute. All right, let's go over here. Now, I could find the edge sitting out, it's stuck out a little bit. I could also find the back end of this vise, because that's the same plane. It's the plane that runs in this direction. In fact, I'll do it that way, just so you can see what I'm talking about. And it might actually be easier for you to see it. Okay. Okay. It's smoothed up against the back part of the vise, so I happen to know that that is. Now, I can zero it. I've got to go through the same process, though, of moving it a 1/10 of an inch, 0.1 up there on the digital readout, if you can see it, but you can't because I don't have it oriented that way. But you can see up there now that I've now set it to be exactly in line with the back part, what is now going to be a 0. It's also 0 on the drawing, and we want to come down 1.15 inches. Take out the edge finder and put in our end mill. Oh, and we've already known that this is a 1/4 of an inch end mill. There we go. Don't leave the wrench up there. You'll do it once if you do it. And you're going to have to calculate how far over you're going to be for your final cut, and then figure out where you're going to be for what would be called hogging it out. And for the depth of cut, it's going to be exactly wherever the end mill starts cutting into it. So if you watch this as I'm coming in here, as soon as it starts to cut, it's just starting to cut. Now I'm going to zero the y-axis. I mean the x-axis. Because now if I go that depth of cut, it's going to be exactly where it needs to be. Now what you've got to do is figure the distance to the edge, and where your final cut would be is going to be 1/2 of your diameter, 1 radius worth, or in this case, since this is 0.25 diameter, 0.125. So I'm going to calculate up here. I'm going to have this, and I'm going to add 1.15 plus 0.125, and I will know that my last pass at this point is going to read out on the y-axis 1275. So I want to go a little bit beyond that. And I'm going to calculate to leave 50 thousandths at the end. So I'm going to start my cut at 1.295. So 1.295. It's going to vary with your depending on the size end mill. So you have to make this calculation. You can also make the other calculation in the other way, but I'm going to let you figure that one out. You'll have your drawing, you'll have your part, you'll have the drawing before that, and then we're going to start hogging this out. I'm going to go in nice and slow. You're taking a lot of material off here, so you want to be careful and do a very slow feed rate, because it's a little tricky cutting a full swath like this. This is about the maximum thickness you should be trying to do. Particularly want to go slow the first time. When you're cutting your other parts out, it'll be only cutting on one side, so it won't be quite as tough on the end mill. And this depth, this slot is 0.550. So, and I want to make one final pass, so I'm not going to go to 0.55. I'm going to go to 0.5. But you see, you can see that I'm going out. You can see that I'm coming back in, and again, I'm going to go to the digital readout, gets to 0.5. Ish. Now I'm going a little faster now because I'm not cutting the full depth. Now I'm not going to, well, you'll have to calculate where that other one is, and believe me, it'll be very simple for you to do that. And let's assume this is the final cut. This is not going to be your final dimension, but now I'm going to go to the full depth. A little too far, but that's all right. I'm going to go back this way till I get to my original location. And if you remember, that first calculation was 1.295. So, coming up on it. Smoothing it out right there. Oh, actually it was 1.275. That was where I started that cut. And I'm watching the digital readout as much as I'm watching the cutter. And you can see the slot. Now I have to go to the drill press to finish drilling these holes, and one of them is a tapped hole. I'm going to show you about how to do that also.